Okay, for our third and final example of solving a differential equation using the method of undetermined coefficients, we'll take y triple prime plus y double prime, 3y double prime is equal to 2 plus sine x. So this is my g of x on the right-hand side. This will be my g1 of x, and this will be my g2 of x. We'll worry about that after we do the homogeneous case. So the homogeneous solution, we take the characteristic equation, set it equal to 0. Characteristic polynomial and set it equal to 0. M cubed plus 3m squared gives us 0. So that means we factor out an m squared. So we've got m equaling 0, 0, and negative 3. So 0 shows up twice. Let's deal with that first. That means if 0 were a unique 0, it would be e to the 0x, and then times some constant out front. But it's not unique, so then we need to do c2x e to the 0x. And then for the distinct one, we get plus c3 e to the negative 3x. So I will write that as, and by the way, that's our complementary solution, or our homogeneous solution. It's going to be c1, that's just c1 because e to the 0 is just a 1, plus c2x, plus c3 e to the negative 3x. I'm going to box that in as our homogeneous solution, and I'm going to erase the rest here, just in case I need the room. So we know the homogeneous solution, now we'll find the particular solution. So what do I want to guess? Well, for a constant, I would normally say, let's guess y particular. This will be for this y particular 1 and y particular 2. I would normally say guess a constant, like a capital A. But a constant shows up in the homogeneous solution, so I can't do that. So, can't do that. So then I say, all right, well then multiply it by x. That'll take care of it. Well, no, it won't. We already have ax right here. So I got to do it one more time. I'm going to choose ax. Actually, if this is the same, is a copy of something in the homogeneous, I would have to do this. If we're talking about a linear equation or a polynomial. Ax plus b is just c2x plus c1. So now I've got to go to ax squared plus bx plus c. That's going to be my guess. So ax squared plus bx plus c. All of that for just this one right here. Okay, so then I take y p1 prime is going to be 2ax plus b, taking the derivative. I need to go all the way out to the third derivative. So y p1 prime prime is going to be the derivative of this, which is just 2a. And then the derivative of that's going to be a 0, and we'll be done with doing the derivatives. All right, so this plus 3 times, let me write down 3y double prime. 3y double prime is just 6a. So that's going to give us 6a is equal to this guy right here. 6a is equal to this guy right here. Actually, just the 2. So all of this tells us that 6a, which is 3y double prime plus 3y triple prime plus 3y double prime, is just equal to 2. And that gives us a equals 2/6 or 1/3. So, with B and C being zeros, we end up with yp1 equal to 1/3 x squared. Yeah, B and C don't appear, so they're just constants, and we'll choose the constant 0. Okay? Okay, so that was like g1 of x. Now we're going to go to g2 of x, where we have to guess something completely different. When we have a sine, we have to guess a linear combination of sine and cosine. So for y particular 2, we're going to guess a cosine x plus b sine x. And we've got no redundancy between that and the homogeneous solution, so we're good so far. All right, now I need to take all the way to the third derivative here. That's not too bad, really. yp2 prime is negative a sine x plus b cosine x. And then I'll take the derivative of that again. I'm going to look at my notes to make sure I don't miss a negative sign somewhere. The yp2 double prime, negative a cosine x minus b sine x, and y triple prime is equal to a sine x minus b cosine x. So we're going to take y triple prime here plus 3y double prime and set it equal to sine x. So y triple prime plus 3y double prime equals sine x implies, just by doing substitution, a sine x minus b cosine x minus 3a cosine x minus 3b sine x is equal to sine x. So I'm just going to kind of circle the like terms. We've got two sines, and I'll underline the cosines. So we know that if I just did some rearranging here, just the two that I've circled, a sine x minus 3b sine x is equal to 1 sine x. That means that a minus 3b is equal to 1. And there's no cosine on the right-hand side, so these two right here have to add up to 0. So negative b cosine x minus 3a is equal to 0. And I won't do the substitution or the addition, elimination method. You come up with a equals 1/10, b equals negative 3/10. I'll let you do the linear algebra work there. So that tells us that. Here's our solution. Now we know a and b, so yp2 is equal to a is 1/10 cosine x minus 3/10 sine x. So I'll write out the entire solution, which would be the homogeneous plus the particular, but the particular is yp1 and plus yp2, so we get c1 plus c2x plus c3e to the negative 3x, that's the homogeneous part, plus 1/3 x squared plus 1/10 cos x minus 3/10 sine x. This is the final solution to the problem.